Welcome Om Mahalakshmi ma'am, and I would like to give a little bit brief of Om Mahalakshmi ma'am. Om Mahalakshmi ma'am have completed graduation in the year 2022 in RBJ and JCCE under the stream of Electronic and Communication. Currently, ma'am working as a trainee engineer at ARAI. Experience of 1 year. Ma'am joined technical member in EBAHA in the year 2023. Now I would like to welcome Om Mahalakshmi ma'am and requested Dr. Ravi Shankar V. Chaudhary sir to please facilitate the sampling to Mahalakshmi ma'am. Now I request Om Mahalakshmi ma'am to please give a beautiful presentation and session to the students.
Good evening, everyone. I'm audible. So this is the last but one session for today. I won't take much of your time. It's just 15 to 20 minute session. Let's go quickly into what exactly the wiring harness and HVI tells about. Uh, so before defining what exactly the wiring harness is, I would like to describe some of the topics, the jargon of wiring harness, and later we'll go into HVI, its definition and its uses. So the first topic, before discussing about the definition of wiring harness is the wire. Wire is nothing but a strand of metal which is used for conduction. A metal is responsible for the conductivity of electricity. So in electric car, we use wires for the flow of electricity from one component to the another component. So when we are selecting the wires, let's say when you are selecting a motor, you will have some parameters like power, the motor torque, what should be the torque, what should be the operating voltage, frequency level, etc. So similarly, when you are selecting a wire, you should know some of the parameters which has to be considered, like inner and outer diameter, like how much insulation should be there, what strand of wire need to be considered, the standing ratio, the flammability UL 94, which will define if a wire is tested at this particular flame rate, how it should behave. So all of these parameters need to be considered when you are selecting the wire. So some of you might have a doubt like why can't we use domestic grade wires for the automotive applications? So the domestic grade wires are something which have a single strand of metal in them. A single strand of metal doesn't hold much of power. If you come into the EV applications, you will deal with high power signals. So for that we use multiple strands which are insulated using the metal. Using some insulation on top of the sheet will be there. And some of the disadvantages of domestic grade wires are like they are low temperature withstanding capability. So we have already come into the automotive grade wires. The automotive grade wires are classified into two sectors: signal harness and the power harness. As Raymond has said that when coming into the Baha perspective, the high voltage and low voltage definitions will vary. Like the low voltage will be of 0 to 15 and the high voltage will be up to 60 volts. Here I have mentioned the normal automotive grade wires. So the low voltage is mentioned as 0 to 60, but since we are talking about Baha, it will go to 0 to 15 volts, and power harness will go up to 60 volts. That is why I have given the examples. The throttle and brake will come under signal harness. Why? Because if you consider the throttle pedal, it is just of a 0 to 5 volt signal, which will send response to the other ECUs, electronic control units that are present in the vehicle. So these doesn't hold much of the power. That's why we have defined it in a signal harness level. And in the power harness level, we have defined the high voltage components like motor, battery, and charger. Can harness. Okay. So when we are discussing talking about electric vehicle, generally the communication between one component to the another component happens using a CAN protocol. That is a common protocol which is used in almost all the electric cars. In case if the car is having, if the EV car is having ADAS facility or ADAS feature, which you will see in a AVAHA perspective. So at that time, you will use automotive Ethernet as a communication protocol, and the other protocols like GMSL, FPT, etc. for camera sensors, lidars, and radars. So CAN harness is a twisted pair of communication, which is used for the communication between the control units. Now you might know which wire to choose for what purpose. Let's have a quick overview of the schematic of this wiring harness. So this is a basic schematic. Here they are properly classified like from which component to which component the high voltage will be present, and the components with the LV are present, and each order is something which is transmitting the data using the signal cable, and CAN communications also you can see. Okay. Since we have seen the theoretical part of this wiring harness, let's go into the safety practices. Why? Because I don't want you guys to land up in a situation where you burn on the workshops of the colleges. Okay? So just know the basic differences of what wire is for what purpose. When you are joining the wires, so just align them properly and then solder them and then put a shrink tube on top of it so that the electrical conductive part, whatever is there, that will not be accessible to any person. So that is how you have to ensure the safety. So we have seen a normal traditional method of how to join the wires, two wires. So in case if you go into the highest level, like in normal electric car, we don't normally join the wires and put a shrink tube on top of it. We use connectors, we use terminals. So when the conductive part of wire, whatever is there, that it need to be put in the terminal, and you have to crimp it using the proper crimping tool. So when you are buying the terminals, you have to ensure you are buying proper mating connectors, mating terminals, the plating, the hole size and the profile. So let's get into the next level of this wire joining when you are using it in a proper tidy way. The next one would be the connectors. So these are helpful in joining the electrical circuits, and this is easier to assemble. So now the wire you have already crimped it, and these crimped ones will go into the connectors, and that is how you make two connectors properly. So last person in this list would go to the fuse. But this is the one of the most important topic when you are considering your wiring harness. As earlier said that you have to maintain a fuse compulsory after your battery. So fuse is something which is used for shock protection, and it should be of water and dust proof. We have the types of fuses like glow fuse, slow glow, and multi-ST fuse. Okay, so as we are done with the main topics of this wiring harness, I would like you to ask exactly what you are thinking of wiring harness is. Can anyone define? I think it's a basic definition. What exactly the wiring harness is?
Connecting the wire properly and reading cable.
Okay. So yeah, wiring harness is the combination of that wires, assembling of that wires properly. And the next topic is HVIL. HVIL is known as high voltage interlock loop. This is actually a LV signal which flows through all the high voltage components and ensure that your system is proper. So the main use case of this HVIL is it ensures that there is no fault in the system, and in case if there is a fault, it isolates high voltage and low voltage. As I'm working specifically on hardware in loop systems, where we do test electric vehicle cars. So I would like to explain one of the condition where how the HVL is used. So let us say your car is moving at a speed of 30 kmph, around like that. We do have two accelerator pedal sensors for the reliability. Let's say one of your accelerator pedal, which is actually a 5-volt signal, is transmitting a signal of 12 volts as a feedback signal. So which is like a faulty condition. Instead of 5 volts, it is somewhere giving you the 12 volts, which is a fault condition. So, and the vehicle is in movement. At that point of time, your battery should automatically go to the ready state. It should not be in a discharge state. So that is where the HVL comes into picture. It will open the loop and it will isolate the high voltage components from the low voltage components. Uh, before you start your wiring harness and your proper wiring circuits, these are some of the basic guidelines and important guidelines from the technical committee of EVA. So you have to first read and understand the rule book. Try to make the drawings of what exactly how you are planning to do your wiring harness and all. Choose the proper wires and connectors, and once it is done, place it. Do not place it in the vehicle directly. Test it outside. Once it is functioning properly, only then you place it in the vehicle. And that is how you can ensure your wiring harness is proper. Thank you.
Okay, welcome again. This is the last session for this today's workshop, and tomorrow again we will be starting at 9 o'clock. Yeah. We have already discussed this. These are some parameters limitation on EVA that is related to the voltage and voltage of reactive, auxiliary, max, usable power. This means how much we can use. So at any point of time, we are going to use only 9 kilowatt. If it is more than 9 kilowatt, anyway, your fuse will be blown. Yeah. So before going into powertrain, whenever you are doing any electric vehicle, you need to consider these parameters. So first we need to consider the parameters from the vehicle side. Then only we can decide what type of powertrain can be used. So if you see the weight is also important, and drive and whether you want to go for manual or CVT, which one is suitable for you, and speed also. Like our vehicle speed is not more than 60. Average we are getting 30. No, no. When you are considering powertrain, when you are considering for designing the vehicle, you need to consider 40 minimum. That is speed. Minimum in the sense vehicle should not go with minimum 40 km. Whenever you are designing, you should keep a minimum target of 40 km. If you are still targeting for 30 km, your vehicle will never go more than 30. Since your design speed is less than 40. So we expect 40 should be the minimum for designing the prototype. Right? Anyone has any idea? So, yes. For brake test, we need to achieve the speed of 40. If you are not achieving the 40, I think you will be disqualified. So consider that minimum 40 km criteria accordingly design the prototype. And what will be the current consumption and all. So all these things you need to summarize first. How much you are expecting vehicle range also. Accordingly, you need to design the battery capacity rating. So all these things will matter. When once you have decided everything, you can go with the motor. Before selecting the motor, these are some points to be considered. So as I mentioned, type can be anything, whether BLDC or PLDC or three-phase induction motor. But how about the output, output current values? And all, you need to know, you need to see that. So once you see the graph, then you will get to know whether this motor will be suitable or not. And accordingly, check the certifications also. Whenever you are purchasing this motor, whether they are providing a certificate or not. Just mention that. When it comes to battery, there are many parameters in the battery. It is not limited to this slide. There are many parameters, but these are most important parameters to be considered. One thing is anyhow, we already know the cell chemistry, whether to be used, what to be used, LCO or LFP or LN, out of all these, which cell has to be used? You can have that depending upon the minimum to max cell rating or a specific energy density, specific power. All these parameters are important for the cell. And then voltage rating of the battery, not on a cell level. Battery is very important. So once you select the wrong battery, then it will be of no use. And ampere hour rating, what will be the discharge rate, what will be the charging rate. So, does anyone know which rate is more, charging rate or discharging rate? Which will be more? Yes, discharging rate will be more. When you are charging, whenever you are charging any battery, not only our vehicle battery, whenever you are charging your phone battery or any single battery, you should always prefer slow charging. As and when you do regularly fast charging, your battery will go. Similarly, in our this one also, you everyone will observe charging rate will be always less than 1C. So next time when you are checking the battery specification sheet, just check what is the discharge rate of a battery. Oh, sorry, charge rate of a battery. Charge rate should be always less than 1. That is specifically preferred. It has to be like that. If there is more than 1C, that means you are intentionally charging more than that and you are damaging the battery. So just ensure, and you can check in the specifications also. That will be definitely less than 1C. But charging rate, discharging rate will be more than that. Maybe 2C, 3C, 4C. That all depends upon your power requirement, how much you need at random. Suppose continuously you are consuming 8 kilowatt, so your discharge rate will be more and it will be drained up very fast. Everyone knows, right, what is 1C and what is 2C. See, if you want, you can check it in Google as well. That's a simple concept. It always depends on how much duration will come based on vehicle rating, current rating. Yes, and self-discharge rate. That should be more or high. Self-discharge rate. Whenever you are choosing any battery, what should be the self-discharge rate? Yeah, it should be less. So whenever you keep the battery in idle, it will slowly discharge. So this rate should be less. If this is less in the sense, your battery is maintaining voltage more less. So this should also be one of the most important factors whenever you are considering battery. Regarding the PMS, there are many parameters that you can check with the vendor directly, whether they are providing smart PMS. Smart PMS is nothing but you will have control on that. In normal PMS, they will just say it has a controlling techniques, but they will not say how exactly it will measure and what is the, suppose if you want to keep certain limit on your own, you cannot keep in some PMS. So those are fixed BMS. Like you can say as a hard BMS or normal one. So if you purchase that, you will have no control. Whatever they have said, accordingly you need to follow. But in smart BMS, they will give you a provision to enter the values. I should not draw more than 10 and 10 or something like that. So it will definitely not cross your set limit in a smart BMS. So all these are important parameters and controller. As I said, this is also the brain of the vehicle. So if this is good, then your vehicle will definitely run. This is the only parameter where all the teams will struggle. So if you maintain your controller very well, then you have done half of your job, not half, more than 75. So before choosing the controller, you need to choose first of all what is controller, what is the work of this major work. What is the major work? Does anyone have idea? So before leaving this hall, at least you should know what is what is the component. Suppose if you ask about DC-DC, what is the function of that? Why it is needed in the vehicle? And what is motor? What is a motor? It converts electrical energy to mechanical energy. So we need that. And what is a battery? It is our energy storage. So it is also required. And what is controller then? Why it is needed? What is the main function of that? Controls in the sense it is almost like a microprocessor. You can use that by controller. It is like just regulating them. Regulating them. If you need according to your input, that means your software will also do, or maybe your microprocessor will do. Isn't it? So what is the main function of the controller? Why do we need?
So like we are pressing the throttle and then we are getting the signal into the controller. So controller is providing the power according to this to the motor.
Okay, it will definitely provide. So maybe you can directly use any resistor kind of things and you can directly regulate power as per the command from the throttle. So I'll tell you. The major work of the controller is to convert the supply DC to AC. That is required. That's why you are using controller. What your motor accepts? Sorry? What is it? Okay, good. Your motor will accept only AC, but you have a DC supply. So how do you connect that? That's why your controller is needed. The major work of the controller is to convert supply from DC to AC. What do you call DC to AC? Which device? Sorry? Technical term in electrical. Yes, inverter. In your home also you get AC. AC supply via inverter. That means you have battery pack that is converted from DC to AC. The opposite to the inverter is rectifier converts AC to DC. So that is the major one. But whenever you are converting DC to AC, there might be two categories. One is a trapezoidal output that is also varying from positive to negative, but there is one more sinusoidal. So the more sinusoidal you get, the better output you get. So the controller efficiency can be defined as a output ratio of this sinusoidal ratio to the DC. So this is how efficiency is calculated for the controller. Obviously, almost all the controllers are saturated. You will get good controllers in the market, but only thing is whether you are able to communicate with the controller or not. That is the question. You will get a good controller, but if you are communicating with the controller, then there is the game. Because you should have an access to give some inputs to the controller. Suppose if your motor is of 10 kilowatt, let us say, here you can keep the limit in a controller. Suppose if my motor is demanding more than, because anyhow motor is 10 kilowatt, it doesn't have any problem. It obviously tries to pull the 10 kilowatt. So whenever it is trying to pull the 10 kilowatt, we'll keep the limit in the controller. Don't give more than 9 kilowatt. So that parameter will help you to save fuse and MCB. Or else, suppose if the fuse is blown, nothing to worry. You can replace the fuse and you can continue. But here you will waste the time. In endurance, you should not waste a single minute of. So accordingly, you need to plan. So if it is open to the users, communication to the controller, if it is open, then I always prefer you to go with that. Then, if it is not available or if you are not getting that type of controller, then go by manual controller. There, they will also have some parameters, but those are fixed and kept internally. You will not be able to change anything. And if the communication is open, you can log the data, you can see what is going on in the vehicle, and if anything happens abnormally, you definitely get that from the basis. Because from the controller, you can log the data, and if anything abnormal happens, you can definitely get to know. There is always good practice for the engineer. Before developing anything, you should have a habit of taking the data. So if anything happens, then you can analyze the data and move ahead. It is not like a trial and error based. Control is also a costly part. It will come around 35 to 40,000 if I am not wrong. So you should not invest again and again. So whenever you are purchasing, you ask the manufacturer what are the provisions you will have. When you purchase the controller, what are the advantages you will have. Just take the advantage from them and then go accordingly. Because we have seen so many things in the event. Before the event, they will not test anything. Directly they come to the event, and whenever they are doing suspension, traction, or manual routine, definitely their controller will go. So there you will face a problem. So before coming here, test your vehicle perfectly with the existing controller, and come to the event. There only you get to know what exactly is happening in the test phase. Because it is a very critical part and sensitive also. Yeah, I have already mentioned this BMS selection in the battery slide. So whenever you are taking the BMS, just ensure that you are considering all these parameters. Because whenever you purchase any battery, and if you are trying to purchase BMS separately, there should be a configuration setting available in the BMS. If the configuration setting is not available, then there is no use of taking that BMS. So when you purchase BMS separately, this one will be useful. Whether are we able to give the settings, series and parallel configurations number. This problem occurs only when you are purchasing BMS separately. Usually manufacturer will give the battery with BMS only. But if he is not giving that, then you need to go for a manual BMS. Separate BMS you need to purchase. But when you are purchasing that, these parameters will be helpful. And then this is for our vendor parts. Whenever you are taking motor or something like that, you can obviously test it. This is related to the controller I have kept. You can just go through that before taking any part, whether it is okay or whether it is used part. You just need to ensure that, and then a no load test and load test should be done before taking it. You ask the manufacturer to demonstrate that. If the performance is good with the no load and on load, you can take control. Yeah, this is generally the block diagram. You can see the charger. It is not a permanent one. That's why I have kept it in a broken lines. You will come from the traction battery. So traction battery is to the contactor. Input fuse is there. That will come under detailed diagram. This is just a block diagram. So you will have a contactor. After that, motor controller. Then motor controller will provide the supply to the motor. After motor, you will directly take to the gearbox or CVT motor. This is the generally block diagram for electric vehicle. There you can see I have kept DC converter. This is possible when you are using DC, or else you can directly keep auxiliary battery in terms of that. So this is a general rough sketch. This is not a final sketch. I just want to mention each and every component here, but there is no startup sequence included here. And a few components might be missing here, but for your reference, I have drawn this. Just to get the basic idea, and on this you can definitely work on it. From this, this will be useful for you whenever you are doing from the scratch. This will be a basic, what I can say, schematic component. Yeah. This is the final topic I can say or slide for the today. How to activate the electric vehicle. So in generally, teams will waste some of the time here for activating the tracking system. So when you sit in the vehicle, directly your vehicle will not move. So what is the procedure? First you need to turn on the ignition. So the first one is ignition or master switch must be turned on. So what will happen when you turn on the ignition key? You will have 12 volts in the system. So once you have a 12 volts in the system, you can play with it, whatever you want. With this 12 volt system, we can activate 14 volts tractor system. So that is our agenda. With the 12 volt system, we need to activate 14 volts. When the 14 volt system is activated, then only your motor should move, like your motor should respond according to the throttle input. Before that, your motor should not rotate with respect to the throttle pedal. That means you sit in the vehicle, you directly press the throttle pedal. In this case, vehicle will not move. Actually, this should not happen also as a safety concern because anything can happen at any time. Your 40 volt supply is directly connected to the motor every time. So if someone presses accident by mistake or if you park the vehicle also, if something happens on the throttle pedal, then directly it will go. That's why to avoid that, 40 volt system should be connected to the battery, should be connected to the motor after certain actions. That actions I have mentioned, what to be considered, and if any of those conditions are not met, then your system should not get activated. So your 40 volt system will not be there. You just have a toggle system. So for this, to activate this concept and all, we need 12 volts. That's why when you sit in the vehicle, you turn on the ignition key. So you will have 12 volts there. Now at this point, brake light should work because you have 12 volt system. Your brake light should work irrespective of the tractor system. Whether your vehicle is moving or not, that is different concept. When you have 12 volts in the system, when you have turned on ignition, your brake light should work. And then, so the first criteria, when the 12 volt system is activated, your microcontroller should take the input from different sensors, whether charging is in progress or not, whether kill switches are energized or not, gear position is in neutral or not, and the one thing is accelerator pedal is in pressed condition. What is the position of the accelerator pedal? All these conditions will be given to the microcontroller. We are not ensuring. Obviously, when you turn on the ignition key, your microcontroller will be in a position to read this data from the sensors. So if your microcontroller has satisfied all these conditions, like microcontroller has got the input that your gear position is neutral, accelerator is not pressed, kill switches are also energized, those are not in pressed condition. So when these conditions are met, the last input is you need to activate the like whenever you try to activate the system by pressing the brake pedal and a dedicated start button. Those two should be pressed simultaneously. So when these two are pressed simultaneously, your active tracking system should get activated. Suppose if the gear position is in forward, and then you try to activate by pressing the brake pedal and stop, vehicle should not get activated because your microcontroller will not allow you to do that. So your microcontroller will be in position to continuously monitor this. Continuously in the sense in the initial conditions. In the initial conditions only, when you turn on the ignition for the first time, it will read for the inputs, three inputs, and if you try to activate it, it will get activated. Or else, suppose if someone pressed the kill switch or someone kept the vehicle in a neutral position, forward gear or reverse gear, though you try to activate the system, it should not get activated by doing that action. But this action should be done manually. Brake pedal pressing and stop button pressing. Like how you crank the engine in active vehicle. You need to press the brake pedal and you need to press the self-start button, right? So accordingly, we need to do here. If there is any problem with those three conditions, then you should not go into the active mode. So when this mode is activated, when the battery is connected to the controller, then your TSL should come on. That means tracker system activate because you have the 40 volt system. That will give the correct information. If you are turning on the TSL before itself, then you are providing a wrong information to the bystanders or passbys, whoever are there. And at this point of time, RTO should also come on for a few seconds and then it should go into the sleep mode. From here, if you press the accelerator, motor should respond. So this is the one point we'll check in the TI. We'll turn on the ignition and we'll ask the driver to press the accelerator. If the vehicle is moving, it is wrong. Immediately it should not move. So whenever you turn on ignition, your microcontroller should take that input and the last command is still pending from your driver side. When you do that, then only it should get activated. If anything is not satisfied, then your vehicle should not go into the ready to drive mode. So this is the sequence you need to implement with the help of any microcontroller. Think about it. You have a 12 volts in the system. You can plan to have a different sensors or take the data if sensor is available and give the input to the microcontroller, code it. This is a customized code, nowhere it is available. Either you can use Arduino or any Raspberry Pi, whatever the microcontroller you are comfortable. You can take the inputs and you can code it. Output will be yes. So one second. All these three conditions are satisfied, when you press this, vehicle will be activated. And it should not be like whenever it is going to forward again, it should come out of this. So till you do that action, microcontroller will be in an active position. Once this activity is done, once the system is activated, practice system, then microcontroller will not do anything. It will be in an idle position. It will continuously give the supply. That means it will continuously give the signal that active group, practice system. But again, if someone presses the kill switch, it should come out of the tracking system. If kill switch is pressed, then definitely vehicle should come out of the tracking system. And when you energize it again, it should not go into the ready to drive mode. Again, the case will be from there. Ignition key should be turned on. From there, you can follow that. So this is actually a good sequence. You need to work on it. This part is the only thing you will apply engineering in electrical point of view. Other than that, क्या होगा मुझसे बैटरी खरीदेगा, मोटर खरीद लेगा, दोनों को कनेक्ट करना है. वो भी as per specifications you can connect, specifications or connection diagram you can connect. But this is where your actual electrical engineering lies. So just work on it. If you still have any doubts, you can definitely ask your electrical mentor. We have already released that. Every team has been allocated to particular mentor. You can directly ask them, or else you can directly call me. My number is also available on the Dana website or in the electrical mentor list. You can call me. Yes. No. For that also you need to convert it then. Convert into yes. You have 12 volt system. If your microcontroller is working on 5 volts, then it is your job to convert it to 12 to 5 and making available for the microcontroller. Accordingly, you should plan. Only with the help of 12 volts, you are activating the 40 volt system. Yes. So the one last one, whenever you have a problem in the vehicle, electric vehicle, don't get tense. As per this troubleshooting circuit, you can get it done. First, go through whether the battery is okay or not. Next, controller, fuse, HV connector, motor. This is what the possibility we have given as per the observations from the previous years. So this is very important troubleshooting. Every EVA team will face this. One or other thing will definitely happen, but how to check that flow and all is mandatory. Thank you. Thank you.